Hello, my dear students. A warm good evening to all of you. It's been so long since I posted a video. I'm very glad and very happy that I'm restarting my YouTube channel again, just for the purpose of making all of you fascinated and attracted towards mathematics. So, starting from this 2026 batch onwards, I'll be uploading regular videos for all of you, and I'm giving you an assurance that I'll be keeping in touch regularly with you guys with a lot of quality contents and all. So for the 2026 batch, first of all, we are going to upload the videos of 10th standard mathematics NCERT syllabus. Once after we have done with it, we are going to do 12th standard NCERT. So with a lot of quality contents waiting. So first of all, in this today's video, we are going to see real numbers, the first chapter of 10th standard. So it's a very interesting chapter, and I have created a lot of interesting notes also. So let's keep rocking. Hello, good evening, everybody. So here we are going to see the first chapter of 10th standard, which is real numbers. So we will see all the things one by one. I have highlighted all the important concepts and I have given enough examples for you all to understand. And here it is. So I am sharing with you all the important conceptual notes. So here in real numbers, you have two topics mainly. First thing is fundamental theorem of arithmetic, and then proofs of irrationality. So under fundamental theorem of arithmetic, you have got so many classifications like HCF and LCM, finding HCF and LCM and all. So I have listed out all the key concepts and along with the examples. So FTA, so this fundamental theorem of arithmetic, this is basically, it states every composite number can be expressed as a product of two or more prime numbers. I have given you some examples. 15 is a composite number which can be written as 3 into 5, where 3 and 5 are both prime, and 30, you have 2 into 3 into 5, all these numbers are prime numbers. And 175, if you can prime factorize it, and you can write this as 5 square into 7. So 5 into 5 into 7, everything are prime. So this is just basically nothing but FTA. And here under FTA, you got different models. First is prime factorization method, which we have solved here, and then HCF and LCM. So I have given you the working rule, and I have also given how to find HCF and LCM for two set of numbers and also for three sets of numbers, and also checking whether the number ends with 0 or not, and then applications of HCF and LCM. So we will see some of the examples of prime factorization. So I have taken two examples which are from the NCERT textbook, which is 140 and 3825. So 140, you have to divide it with the first prime number. You have to check whether it is divisible by 2 or not. If it is divisible by 2, so you have to proceed. 140 is divisible by 2, so you get 70, and 70 is again divisible by 2, you get 35. 35 is not divisible by 2 or 3. Then you have to go for the next prime number, which is 5. So 7 and then 7, 1 till 1 comes, you have to do. So 140 now can be written as 2 into 2 into 5 into 7. So 2 square into 5 into 7. So this is basically nothing but FTA. So here in 3825, similarly it can be done by using prime factorization as 3 square into 5 square into 17. Next we have HCF and LCM. So here in HCF and LCM, we have the golden working rule here, which I have given. So for HCF, please listen carefully. I have given you some lot of examples here, so you can understand it better. So for common factors in HCF, for common factors, you have to choose the value of the least power. You have to consider only the common factors, and in common factors, you have to choose the value of the least power. And for LCM, you have to choose both common factors as well as non-common factors. Under common factors, you have to choose the value of the highest power, and all other factors to be used minimum of once. So here in HCF, you have only common factors to be considered. So I have solved an example. Let us understand these examples better. 6 and 20 and 96 and 404 I have taken. So 6 can be prime factorized as 2 into 3. 20 is prime factorized as 2 square into 5. Now you see the common factor between 2 and 2 square. I mean 2, 3, 2 square and 5. You have 2 as common. So under 2, the least power, which is the HCF, which is 1 here. So HCF is 2 power 1, which is 2. And LCM, for LCM for common factors, you have to choose the highest power. So 2 square, and remaining factors are to be used once. So 2 square into 3 into 5. So this will give you 60 as the answer. Similarly, 96 can be prime factorized like this. 404 can be prime factorized like this. So common factor is 2. Under that, the least power is 2, so HCF is 2 square, which is 4, and the highest power between the common factors is 5, and the remaining things to be considered once. So 2 power 5 into 3 into 101, which will give you 9696. So always remember, when two numbers are given, there is a specific rule to be followed. It is valid only when two numbers are given. So that is HCF into LCM equal to product of two numbers, where A and B are nothing but the numbers. So like this, they will be asked questions. And similarly, here we have another set of examples. HCF and LCM of three numbers, 12, 15 and 21. So 12 can be prime factorized like this, 2 square into 3. 15 can be written as 3 into 5. 21 can be written as 3 into 7. So you have to choose the common factors, which is 3. So HCF is 3, and LCM, common factor you can take 3 power 1, because no powers other than 1 is there. So everything only 3 is here. So you can take 3 power 1, and all other factors to be written once. 2 square into 5 into 7, which will give you 420. So here HCF into LCM, if you multiply, it will not be equal to product of the three numbers. As I said already, it is valid only for two set of numbers. Okay, next model under FTA is checking whether the numbers ends with 0. So I have taken some examples for numbers to end with 0, 10, 20 and 30. Here if you see carefully, 10 can be prime factorized as 2 into 5, 20 can be prime factorized as 2 square into 5, 30 can be prime factorized as 2 into 3 into 5. Here the common thing in all these set of numbers is 2 and 5. At least there must be 1 2 and there must be 1 5. So for a number to end with digit 0, it must have minimum of 1 2 and 1 5. So like this you have to do. They will ask you in your question, check whether 4 power n ends with 0 or not. Like for example, so 4 is 2 square. So here there are no powers of 5, so it cannot end with digit 0. Like that you have to write. Okay, next is the applications of HCF and LCM. I have given you some very key usage where HCF and LCM are mainly used. So for sweet sums, you have to use HCF. And after how many times will the bells ring together, after how many minutes will they meet again, like this kind of questions if it comes, then you have to use LCM. Similarly, largest positive integer which divides, this kind of questions you have to use HCF. So like that I have given. Next we are going to go to the topic of proofs and proving of irrational numbers. So I have taken three examples. Root 2 is irrational, root 3 is irrational, root 5 is irrational. So let us now prove root 2 is irrational. So for first proving root 2 to be irrational, let us assume root 2 to be a rational number. So any rational number is represented by this form, root 2 equal to a by b, where the denominator b is not equal to 0 and a and b are co-primes. See, co-primes means the HCF of a and b should be 1. It need not be prime numbers. Co-prime numbers need not be prime numbers. For example, 7 and 4. 7 and 4, if you see, 4 is not a prime number, but still they are co-primes, because the HCF between 4 and 7 is 1. So like that. So where a and b are co-primes, so that means HCF is 1. So you just cross multiply this, root 2b equal to a, and then you have to square on both sides. If you square on both sides, it will become 2b square equal to a square. So this equation implies a square is divisible by 2. If a square is divisible by 2, then a should be divisible by 2. Since a is divisible by 2, I am just using it, a divided by 2 should be a constant. So that is a meaning. So you cross multiply, a is equal to 2c, and a is equal to 2c, you have to substitute it in this equation. 2b square equal to a square. So you will be getting 2b square equal to 2c whole square, which is 2b square equal to 4c square. So from this you can write b square equal to 2c square, which is b square is divisible by 2. After once proving b square is divisible by 2, we can now prove that b is divisible by 2. So that is both a and b are divisible by 2. If both a and b are divisible by 2, that means what? HCF of a and b should be 2. But as per our assumption, our HCF of a and b should be 1. That means it contradicts our assumption. So if this contradicts our assumption, then our assumption itself is wrong. What have we assumed? We have assumed root 2 to be rational. So that itself is wrong. So that means root 2 should be a rational number. Similarly, I have proved for root 3 to be irrational and root 5 to be irrational. Same steps you have to repeat. Some slight modifications will be there. Instead of 2b square, it will be 3b square. And instead of 3b square, it will be 5b square in case of root 5. Okay, so I have written all the steps here. Hopefully you guys are able to understand. Now let us talk about the last part of the thing, which is very important. That is the properties of irrational and rational numbers. See, whenever a rational number is added or subtracted or multiplied or divided with an irrational number. So rational and irrational, if that combination comes, always the answer will be irrational. You can see here always the answer will be irrational. If any one number is rational and if another number is irrational, if you add, subtract, multiply or divide, you will get the answer to be irrational number. So I have given you these 4 examples. But the thing here you have to note is whenever two irrational number comes and if you add, subtract, multiply or divide, the answer can be rational or irrational. In this examples 5, 6, 7 and 8, I have given where when you add or subtract, multiply or divide two irrational numbers, you will be getting the answer rational. I have given some examples. 2 plus root 3 plus 2 minus root 3. Root 3 and minus root 3 will get cancelled. So the answer is 4, which is a rational number. Here root 5 and root 5 will get cancelled. So the answer is minus 1, which is rational. And here root 2 into root 2 is 2, which is a rational number. Here is 1, that is also rational. And similarly, when two irrational numbers are added, subtracted, multiplied or divided, I have given you the examples of answer being irrational. So these are the examples. Root 3 plus root 2 is irrational. Root 3 minus root 5 is irrational. Root 3 into root 2 is irrational. Root 3 divided by root 5 is also irrational. So with this, we have completed all the important topics in real numbers. I hope that you guys are able to understand all the concepts. So next, we'll be seeing all the important concepts of various chapters. So see you in the next video. Thank you.